Hey Phys One Kids, Mr. C here, and this is the second video for your summer homework assignment. After watching this video, hopefully you'll be able to successfully complete all of your summer homework assignments, so that's pretty exciting. So anyway, to begin, we're going to be talking about rules for graphing, because graphing in physics is going to be a little bit different than graphing in, say, like your math class or even other science classes that you've taken. The first rule is determining what we should put on each axis. And in physics, we do it a little bit different. We don't really care about which one's the independent and which one's the dependent variable. We want the slope of our graph to be a meaningful quantity. And what this means is basically we have to pick our axes such that whenever we take the slope of our line, they give us what we want. So one example of this is, let's say we're measuring the distance a car travels in some period of time, t or something like that, and we want to know what the velocity is. Well, we know that velocity is distance over time. So if we want the slope of our graph to be velocity, we know that slope must equal rise over run. So our rise, in this case, is our y-axis, and if we want it to be velocity, that our y-axis has to be our distance, and then our x-axis would have to be time, or our run would have to be time. So before you even start graphing, think to yourself, what do I want the slope to be, and what do I need to put on each of my axes to get that proper slope? Sometimes in a lab we'll tell you what we want you to graph, and if we ever tell you what you want to graph in a lab, it's going to be in the form of y versus x. So whatever goes on the y-axis will be first, and then whatever goes on the x-axis will be second. So one example of this is if we say do a velocity versus time graph, we want you to put the velocity on the y-axis, and then we want to put time on the x-axis. So it's always going to be y, then x. But this will only happen sometimes. Sometimes we'll tell you this, and other times we'll want you to choose what to plot on the axes by yourself. The second rule is the size and the scale of the graph. So your graph in all of your labs needs to be at least 1/3 of a page. That's roughly the size of your hand, but that's the minimum size that your graph needs to be. It can be bigger. I actually like to make my graphs a full page, but at the very minimum, they need to be 1/3 of a page of paper. If you don't make them at least 1/3 of the piece of paper, we're going to be taking off some points because they weren't big enough. So make sure that your graphs are nice and big so that they're easy to read. Whenever you choose a scale, you want to choose a scale that will stretch the data across the entire graph. So if, let's say you have your graph right here and you make some scale like this and all your data points fall right there, well, now this entire portion of the graph is empty, and we don't want that. We don't want empty space on our graph. A better scale would be to choose something like this, where your data points stretch the entire length of the x-axis and the entire length of the y-axis. So you don't want all that empty space. Empty space is bad. We like to stretch things so that we can see the relationships better, and it also makes reading the graph a lot easier. Make sure that your scales are uniform, that they're equally spaced. Don't make, one line 5 and the next line is 25 and then the line after that is 30. Make sure they're equally spaced. So 5, 10, 15, 20, or go up by 20s, 50s, 100s. You can go up by 1 if you want to. Just make sure that the lines, every time you label it, make sure that they're equally spaced, and use round numbers. Don't go up by like 3, or don't label one of your lines 3.5 or something like that. Always go up by a nice round number, so 1 or 2 or 3, 4, 5. Don't do like 17 and 224. That just makes reading your graph a whole lot harder later on. Your scaling doesn't have to start at 0. So oftentimes people will tell you that they like you to make this point right here 0. Well, you don't have to do that. If your data, say maybe in the x direction, you only have data points that go from 100 to 500, you could start your scale at 100 and go to 500. Just make sure that you make note of it and you tell us, hey, it's starting at 100 instead of 0. Make sure to draw attention to that so that we don't assume that your graph is starting at 0. And of course, you don't have to make your y scale the exact same as your x scale. They could be different. Maybe your whatever's on your x-axis goes from 0 to 1,000, but whatever's on your y-axis goes from 0 to 1. They don't have to have the same scale on each axis. Pick a scale so that the data is stretched all the way on the y-axis and all the way on the x-axis at the same time. So they can be different. Maybe your x-axis goes by 100s, but your y-axis goes by 1 or something like that. They don't have to be the same. Rule number 3 is labels and titles. Make sure to label each axis, and each axis needs to be labeled as to whatever quantity is being graphed. So let's say you have your velocity versus time graph. Your y-axis should be labeled velocity. Sorry about my handwriting. With a unit, meter per second. And your x-axis should be labeled time with a unit. So always have whatever quantity was measured and the unit associated with that quantity. And in the end, also make sure to give your graph a title. I don't like coming across a graph that doesn't have a title. The title should describe what is going on. What does this graph tell me? That's what your title should be like. So this could be like, it's the velocity versus time graph of a car going uphill. Or it could just be the velocity versus time graph of car A. But make sure it describes what's going on. Don't name it something arbitrary like, oh, graph 1. Well, that doesn't really tell me a whole lot about what's going on. Give me a title that explains what's happening in the graph. Make it meaningful. Rule 4 has to deal with plotting the data. Make sure you locate each data by a small dot. So you don't have to do anything dramatic or anything, just a little dot. You don't have to make them really big. Just make sure that we can see them and make sure that it represents the exact point on your graph that you want it to. So, if you make your dot too big, it could represent a number of points. If you want it to represent on the x-axis 1 and the y-axis 5, make sure it's exactly at 1, 5. Sometimes you'll have to be graphing different trials or different runs on your graph. Make sure you differentiate the different runs. So maybe for run 1, you want to use the dot, and then for run 2, maybe you change something and slightly different. You might want to use X's or squares or triangles. Make sure that if you have different runs or different trials that you're plotting on the same graph, you not only change the symbol that you're using to mark those data points, but you also put a key that says, key, maybe the dot is for trial 1 and the X is for trial 2. That way, whoever's reading the graph knows what's going on. Rule 5 is determining the trend line in your graph. So if you look at your graph and it seems to be a linear graph, so all your data points fall along a straight line, you're going to want to draw a best fit line. To draw a best fit line, the first thing that you need to do is you need to use a straight edge. So you can use a ruler or a protractor, the edge of a book. Maybe if you have like a keyboard, you can use the edge of the keyboard, but anything straight will work. If it's clear, it'll be a little bit easier to use because then you can see all your data points, but you just need something straight so you can get a nice straight line. Make sure that they're the same number of points above your line as there are below your line. So in this case, we have, it looks like those 3 dots are above the line, but we have 1, 2, 3, 4, 5 dots below the line. So in this case, we want to shift our line down a little bit so that we have the same number of points above the line as we have below the line. And make sure that this is important, because if we see in your graphs that you don't have the same number of points or relatively the same number of points above and below, you're going to lose some points for drawing your best fit line. Don't ever force your line to go through 0, 0 unless you actually have a 0 value in your data table. That being said, also don't force your graph to go through any data points. Sometimes you'll get lucky and your best fit line will happen to go through a data point, but more often than not, your best fit line might not go through any data points, and that's okay. As long as it looks like a reasonable line for your data set, you will be good. So don't force it to go through 0, and don't really force it to go through any points. It's okay if you don't go through any measured points. That's perfectly normal. The reason this happens is because we have experimental error. If everything was perfect in the world, none of our points would fall off the line and they'd all be in a perfectly straight line in our experiments that had linear relationships and all would be good. But because the world is not perfect and there's all kinds of things that mess with our experiments, we're gonna have data points that don't fall perfectly on that line, which is why it's okay for your points to be off the line. In many cases, I've done many labs where none of my points fall on the line, and that is perfectly fine. So don't worry about that. Just make sure your best fit line has the same number of points above the line as it does below the line, and you'll be good to go. Sometimes your data is not gonna fall on a linear line. Sometimes it might be quadratic, sometimes it might be a square root, sometimes it might be an inverse function. If you ever get something like this, you want to draw a nice smooth line. You don't have to force it to go through all the points like before, but you want your line to basically look like it matches with your data. So here we have the green one, or if you wanted to, you could draw a nice smooth line like this. But once again, make sure you have the same number of points above the line as you do below the line. The thing that you should never, ever, ever do, unless you want to see me get, probably kind of mad, is never, ever do a dot to dot line. We're not doing like one of those cool coloring books that we had as kids. This is physics, and in physics, we draw nice, smooth lines. We don't do dot to dots. We don't like jagged lines. We like our lines to be nice and smooth and continuous. So don't do a dot to dot. If your relationship is not linear, but you're going to have to regraph your data so that you get a linear graph, and you can take the slope of that graph to figure out whatever we want to know. In order to do this, you have to follow the steps that you learned in the previous video for our summer homework, but you have to determine what the relationship is in the data. And sometimes you can tell this by looking at the graph, or other times you might have to look at, maybe you know what the equation of the graph is, and you can look at that equation and determine what the relationship is. And then based off of the relationship, you use your transformation notes and you transform your graph so that you can make a nice linear line. Anytime that you have to manipulate your data, so maybe you have to square a variable or take a square root of a variable or do 1 over a variable, make sure you always add a new calculated column of data to your data table so that we can see what you're graphing. Anytime you make a data point, we should be able to look up at your data table and say, okay, this point here is represented by this number and this number for the x and y axis. And then after you calculate your data table and do all that, you just have to replot the data using the rules that we discussed earlier on in this video. The last thing that you're going to need to do is calculate slope. And the way that we're going to calculate slope is we're going to use the best fit line. And to do this, we have to choose 2 data points that lie on the line. Don't ever use a data point from your table unless it actually falls on the line, which, as I said earlier, is probably not going to happen. So if we look at our example here, none of the data points fall perfectly on the line. So we're not going to want to use any of the points that we actually took. In this case, we use this point here, and we use this point here. And we're going to call this point 1 and point 2. And we're going to use those 2 points that fall perfectly on our line to calculate what the slope is. So we know slope, which I'm going to represent as m, is equal to our change in y, or our rise, over our change in x, or maybe you heard this in your math class, but it's yum-yums over the picnic table. In this case, we're going to take our y of 0.1, which if we kind of trace it over here, it's probably right around 425. So 425 minus our y value from our point over here, which is going to be probably right around 225. All divided by our x value at this point, which is probably right around 19.5, minus our x value here, which is right around 13.5. From there, we can simplify this, and we see that we really get a slope that's equal to the 200 divided by 6, which is going to give us 33.3 degrees, or 33.3, but we're not done here. We always have to add units to our slope, which in this case is dollars per degree Celsius, and that's how we find our best fit line. The most important part here is that you're using 2 points on your line that actually fall on the line. Don't pick points from your data table. Always pick points that are on the best fit line. Well, that's all I have to say about graphing. If you have any questions, make sure to write them down, and you can either ask us on the first day in class, or you can shoot us a quick email and we'll do our best to answer it before the first day of class. But now you have all the necessary knowledge to complete your summer assignment. So good luck, and I can't wait to see you all on the first day of school.